Okay.
Hello everyone. Today I will present our project, Public Health Confidence Interval Explorer. This project is about a dashboard which allows users to explore US public health survey results using the confidence interval across demographic groups. Everything shown in this dashboard is generated from the cleaned and aggregated BRFSS dataset that we proceed through a five-step data workflow. So first, let me show you how we clean the dataset. The first step of the clean dataset is to remove unnecessary columns and unify question ID. So in the step one, we clean the raw dataset by removing columns that do not influence any analysis, such as the first day names, phone notes, display order, or repeated metadata. After that, we unify the question ID. Many questions share the exact same text but have different IDs. So we grouped by the question text and choose the shortest IDs as the standard one. This ensures every identical question now has one clear, consistent identifier, which is important for later grouping. So the second step is about the standardized response IDs and the response text. So in the text too, we standardize both the response ID and the response text. The dataset contains many duplicated and outdated response codes, spelling mistakes, and inconsistent category labels. We merged these old codes into a single correct ID and select one clean text label for each response. Uh, the formula is some example that we have cleaned in our dataset like this. We use the original response ID RESP025 to merge to RESP 137. They are all meaning as the employed. So there are many examples about these merged ones uh, for the response ID. I all list the formula here. You can see. The step three is to standardize and the breakout categories because the original dataset contains many different codes for the same group, such as over 20 age codes or multiple versions of income and education levels. We mapped all of them into clean, consistent labels like the seven standard age group, which is come from 18 to 24 up to 75 plus. Uh, we uh, merged the seven standard age group into five income and the five income levels and unified race, sex, and education labels. If a breakout ID did not match any known mapping, we keep the original text. This step gave us reliable demographic categories for filtering and visualization, which can uh, let us filter by the category in the code. So the next step is to clean the numeric values and calculate the proportions because when we merged this data set and we need to propose the numeric types and remove the rows with invalid. There are some rows with invalid values, such as zero sample size or percentage outside the uh, 0 to 100 range. So we then computed two key measurements to keep the data of the dataset is correct. The first formula is about the proportion is to calculate the data value divided by 100, and the persons is to multiply the sample size and the proportion. This matrix represents the probability and estimated count of each outcome and prepare the data for final aggregation. So the step five is to aggregate duplicates and recalculate CI. In step 5, we aggregate duplicate rows. Some combination of question, response, breakout, year, and state still appeared multiple times even after cleaning. We grouped them into a single row, summed the sample size and persons, recalculated the proportions, and rebuilt the nullified confidence intervals using a binomial formula. This resulted in a clear, accurate, and non-redundant dataset ready for the visualization. So next part we welcome Rongjia to doing the code explanation for our formula for our project.
Okay, cool. Let me just share my screen first. Okay, can you see that?
Yes, we can see it now.
Wait a second. I think I didn't show the correct one. Wait a second. Uh, should be the Visual Studio part. Okay, cool. Hi everyone, this is Rongjia Sun, and I'm going to show you how our code actually work out. Yeah. Mm, Yeah, today I will walk you through about our BRFSS dashboard implementation. This dashboard allows the users to explore public health trends interactively. We built this with our Python Dash framework for web-based visualization. Now, first of all, is our import our data. We use package format instead of the CSV. This makes much faster than the dataset, which is larger than 1 GB. So the data validation ensures all the required columns exist before proceeding. And the typecasting converts strings to float or statistical calculations. And now here comes to the core algorithm. The confidence the, co- the, co- the confidence interval aggregation, which is this part. Yeah, here, this key function. Here, this is the heart of our dashboard, the aggregate function. When the user selects the filter, we need to recalculate the statistics from row counts. The first step is to group data and sum sample sizes and person counts. Step 2 is to calculate the portions. Step 3 is compute 95% confidence intervals using the standard error formula. Why we need to recalculate this? Just cause that we can't just average percentages. Need to aggregate raw counts first. Now, here comes to the visualization functions. Now, let's take an example of the age panels. Let's see. It is. Second. Yeah. Here's our age panel function. This function will create an age group bar chart with more or less granular models. The dash uses a reactive programming model. Users' interaction triggers the callback that updates the UI. The three-level filter cascade class, topic, and questions. When any filter changes, all 7 panels refresh automatically. And now here comes to the main callback logic. Let's just find that. The callback. Yeah, here we go. The one callback updates all the 7 panels simultaneously. That ensures the consistent data across all the visualizations. And we are just using our the React based functions to work out the whole modules. And the entry point is that we just run the dashboard and the development that server. We could just use that for a live demo. Now let's move to our teammates to do the live demo for you. I shall stop the screen sharing stuff. Coming.
Okay, wait a minute. Can you see the screen?
Yeah, I can see the screen.
Okay, now that we have completed all the data cleaning steps and the data show, let me demonstrate the interactive dashboard built from this final data set. So I will switch to the dashboard. So we can see at the top, you can select a class, topic, and the questions that we have. These drop downs are dynamic. Once you select a class, the topic list updates and the question list updates accordingly. You can see here.
Yeah,
This all data change. And after selecting a question, all 7 panels below automatically update. There are seven, I think it's seven part uh, of the dashboard. So the first part is the overall panel. It shows aggregated response with 95% CI. We can see here overall by response. This is had blast, stool, tears. This is had never. And we can see the data when we put the mouse here. It told me that we have never had blast. It is 18.8 and the interval. And the second is the gender part is selected by the male and female, the breakout the male and female, and we can see the data at the same time. You still choose by different answers and response. The third part is age, and there are one more function that we can allow more or less detailed age grouping. So here we can see it's 45 to 54, 55 to 64, and 65 to 74. And if we choose less here, and we can see a less age function here. And for the education part, uh, it used for the for standardized education levels, and we can see here less than HS, HSO, GED, college graduate, different part, different data and different output. So this part is about the income panel. So this is a breakout. We can see here they are all divided by different income of their categories. And the location map is a map that we can see the uh, percentage show on the map. Uh, for example, we choose WY, so we can see uh, the data here. And for the year panel, it shows the temporal of the data for the different year. Uh, this question is not. We can choose. We can try other question. For example, we choose chronic health indicators, anyway, depression, and we can see different answers, which is different year. You can see here. So all of the question and the output is the dynamic when you choose a different class topic and questions, and when you choose more age or less age, they are all different. Yeah, see here. Yeah, so that's all about our dashboard demo.
yeah, I believe that's it. Thanks for your watching. This is the end of our presentation.